Orthogonal and parallel vectors. Recall that if the dot product of two non-zero vectors is 0, then the angle between the vectors is 90 degrees, and the vectors are orthogonal. Note that the standard unit vectors I, j, and k are orthogonal to each other. Now determine whether each vector is orthogonal to the vector w, -2, 1, and 3. So all we're going to do is we're going to go ahead and multiply these. If we get 0, then they are orthogonal. If it's not, then it's not orthogonal. So trying this out, we have w here. So we're going to take -2 times -3, and then plus 1 times -1 plus 3 times 2. So this is 6 minus 1 plus 6. And so we end up getting 11. So therefore, this is not orthogonal. Now let's try the next one. So we have -2 times 3, and then plus 1 times 0, plus 3 times 2. So this is -6 plus 0 plus 6. This is 0, therefore this is orthogonal. So go ahead and try the next examples down here. So trying this out, the first one is not orthogonal, you would get 4. And then for letter B, you would get 0, therefore it is orthogonal. Now let's take a look at determining parallel vectors. So we need to recall from the definition of scalar multiplication that positive scalar multiples of a non-zero vector v has the same direction as v, whereas negative multiples have the direction opposite of v. In general, two non-zero vectors u and v are parallel when there is some scalar c such that u equals c times v. For example, in the figure on the right, the vectors u, v, and w are parallel because u equals 2 times v and w equals -v. So vector w has initial point 1, -2, and 0, and terminal point 3, 2, 1. Determine whether each vector is parallel to w. So first, let us write w in component form. So w in component form, we have to figure that out. And so this is our initial point P, terminal point Q, and so this is going to be 3 minus 1, 2 minus a -2, and 1 minus 0. So the component form of w is going to be 2, 4, and 1. So now looking at 2, 4, and 1, does that relate to u somehow? So I hope you see that if I do, for example, 2 times w, and I multiply this by 2, 2w is going to equal 4, 8, and 2. So because you see that, therefore we have 2w equals u. So therefore, w and u are parallel. Let's try another example here. We have v equals 4, 8, 4. We already have the component form here, 4, 8, 2. So if you see that, 4, 8, 2 versus 4, 8, 4, there's no way that I could make them match, right? They're not going to be the same. So therefore, this is no solution. It doesn't work. And so therefore, they are not parallel. So try out these two examples down here. So first, I hope you found the component form of w, and that is -2, 6, and -4. So you see -2, 6, and -4, and you see that if I cut this in half, so 1/2 of w, I would get -1, 3, and -2. I would get the same thing. So 1/2 w does equal u, and therefore w and u are parallel. For letter B, you have -2, 6, and -4. And so comparing that to V, there's no way that that can happen here. So therefore, it's no solution, and W and V are not parallel. So now we're going to use vectors to determine collinear points. You can use vectors to determine whether 3 points are collinear. They lie on the same line. The points P, Q, and R are collinear if and only if the vectors P, Q, and PR are parallel. So we have to figure out these points here. So let's start with vector PQ, so we'll need to write that in component form first. So we take 5 minus 2, and then 4 minus a negative 1, and 6 minus 4. And so that is going to be 3. 4 plus 1 is 5, and 6 minus 4 is 2. Then let's look at PR. So PR, that is going to be R first, negative 4 minus 2, and then negative 11 minus a negative 1, and 0 minus 4. So we would get negative 4 minus 2 is negative 6. Negative 11 minus 1, that is a negative 11 plus 1, which is negative 10. And 0 minus 4 is a negative 4. So if I'm taking a look at PQ versus PR, if I look at PQ, if I multiplied PQ by a negative 2, I think that's going to work. So negative 2 times 3, 5, and 2, we would get negative 6, negative 10, and negative 4, which is the same thing as PR. So therefore, they are the same. Therefore, they are collinear. PR and PQ are parallel. Therefore, P, Q, and R are collinear. So go ahead and try this last example here. Determine whether the points P, Q, and R are collinear. Trying this out, vector PQ would get 3, negative 3, and 6. PR, you would get 5, negative 5, and 10. And so if you multiplied a third to PQ and a fifth to PR, they would be the same. And so therefore, it is collinear.